Hello, everyone. Welcome to another Howdy Tech Talk. Today, we're going to have our very own Diego Perez, who is going to take us into the world of AI agents using LangGraph. So basically, today, you are going to learn how to build an AI agent that can scrape data, generate insights, and perform tasks by interacting with external systems. So without any further ado, here is Diego. Take it away, Diego.
Sure. I just stuff with TypeScript and JavaScript mostly. So today we're going to be building an AI agent um, with LangGraph. We're going to be learning what is an AI agent. We're going to be building a simple one, and then we are going to progressively start building on top of that, right? We are going to add tools to this agent, which I think is it's a game changer, 100%. This is what allows actually smart agents that are able to interact with external systems. So we're also going to see the final agent in action, and that's what we're going to do right away. And then visualize with LangGraph Studio. We're going to see how LangGraph Studio works and how we can see how it interacts with also multiple agents and how we can compose them. So at the end, I hope that this talk will encourage you to build your own agents. Yeah, and also I think you also realize how simple it is to build AI agents, and that it's actually it builds on top of many of the old school concepts that we already know. Yeah, so if you have any questions while I'm talking, you can just scan the QR code, and I will be able to see the questions, and I will be able to answer as well. So let's go to first. I wanted to show you what we're going to be building, right? Our final agent. So let's get into LangGraph Studio. This LangGraph Studio, yes. LangGraph Studio allows us to see our agent, and LangGraph builds on top of graph theory, right? So what we have here, what we are seeing here, these rectangles, they just represent nodes. Each arrow, that's actually an edge, right? Plain, super simple graph theory. We have a special kind of edge here, which is this dotted arrow. That means that's a conditional edge. We'll be looking into that later. But first, let's see what this agent is capable of doing, right? So let's think about one request or one question for this agent. Let's see. Could you recommend a good wine I can grab at the store and take to the barbecue tonight? Let's see what it does. And again, what will happen is you will see the agent deciding where to go, which node to call, right? So here we see, perfect. And the supervisor is a specialized agent that is able to decide, hey, I think for this request, I would rather talk with this specialized agent. And in this case, it went to the scrapper. The scrapper is a specialized agent that is able to open your own browser or use browsers, get data from a web page, right? This agent specifically returns data in JSON. So it is able to scrap websites and return a structured JSON, which is super important because we are consuming unstructured data. It is returning structured data for us to consume. Now, the scrapper went back to the supervisor, and the supervisor said, hey, next step, let's go to the data analyst. And data analyst is just that. It's an agent capable of analyzing data, understanding your request, using the data that was generated by other agents, and get you something, right? here we see that the recommendation was a Malbec wine for some reason, and it did some stuff here. It thought that this was the best option given the data that the scrapper was able to collect. So yeah, something cool about LangGraph Studio is that we can see how the flow was performed. So we see here at the current step, the supervisor decided to go to the data analyst, right? And then data analyst, since this is, let's say, a plain edge, not a conditional one, is going to always come into the supervisor. So these are, let's say, the concepts for LangGraph. Not very detailed, but we're going to get into that. So for that, before we even go into the code itself, let's first go into what is LangGraph, right? So LangGraph is actually just an orchestration framework, and that's it. You know, if you have worked before with something like Airflow or Prefect in Python, this is it. This is for orchestration, like orchestrating like different jobs together, maybe a scheduling, redirecting, conditional. Yes, that's LangGraph. Now, what is then LangGraph cool? The thing is, they made it simpler to interact with or to orchestrate undeterministic systems, which is what at the end LLMs are, right? LLMs are undeterministic. LangGraph make it super easy to work with in this kind of uncertainty. So to understand LangGraph, we need three basic concepts. First, state. The state is just the data that we pass around between nodes. So each node will have a piece of data, right? And we have then the node. We do work based on the current state, and we return a new one. So when we're in a node, we literally see the state and we realize, hey, this is the current state, what should I do? Then we perform some work on that and return a new state. And then we have edges. Edges, again, are just simply defining the flow between the nodes. And yeah, we have this special conditional edge. What it does is it is able to analyze the state, to get a state or the current state of the LangGraph app, and decide, hey, you know what? Based on this condition, let's go to node B instead of node A, right? So that's what a conditional edge is for. So yeah, once we get these three main concepts, we understand LangGraph, and that's what I like about LangGraph. It's super simple, and you will see that it actually looks. First of all, it's similar to other orchestration framework, and second, it is similar to handling a state in, for example, React or Angular or any kind of UI framework or web framework. So to start learning the actual code, let's look into how to build a simple agent. So here in the studio, I have a bunch of agents, but let's first start with a accuracy converter agent. This is a simple one. Let's start a new thread. And let's look at the code. But actually, let me first show you what it does. So as the name implies, this is an agent that is capable of converting between currency. Let's say, hi, what are you capable of doing? To see what it does, right? So yeah, we go to the chatbot. It says, hey, I'm capable of converting USD to Colombian pesos. Just let me know the amount in USD you want to convert. Great. Let's say I want to convert, hey, how much is $60 in kind, right? And here we see that the chatbot actually went to the tools node instead of doing what it did before, which was literally just chatbot and then ending. Here in this case, it decided to go to the tools node and then back to the chatbot and then ending. So yeah, remember we have here conditional edges. This here pretty much suggests that some condition was met here, right? So here, in this case, the condition decided to go to the end node, and here we went to the tools node. So actually, let's go to the code and see why. First, so let me give you the whole file. I think that allows you to understand what's happening. So this Python, again, this is built using the LangGraph library, LangChain library. Yes, that's yeah, we have a top environment for your environment variables. But let's look at one of the main concepts, right, which is the state. Let's look at the state here. So in this case, and as you can see here, LangGraph Studio allows you to like display what the state or what the agent expects. In this case, we know that this is present messages sequence, which is just a list of messages. Great. That means that in our agent, we're just handling this message state. Now, so that's the state. Let's look at the nodes. LangGraph has this class, which is the state graph class, which pass the state. The state is just, again, a typing for defining the actual state for the graph, yes. This graph builder, as the name suggests, allows to build a graph, right? So we have an add node method where we define the node, the name for the node, and we define the function attached to that node. And the function is just the work we are going to do once we hit that node. Here we can see how this maps. This is our chat node. And here we have also another node, which is the tool node, right? And we have here the stages, the edges. So we have here an edge from the start to the chatbot. Plain, simple edge. But here we have conditional edges. From, the first argument is from the chatbot, and the second is a router function, and we're going to see this later, how this actually is able to, hey, this is the state, and then go here or go there. And the third argument defines the possible path. So we have to declare what are the possible path for this conditional edge, right? And then we have another edge from the tools to the chatbot. Again, edges define the flow between the nodes, and conditional edges conditionally define the flow within the nodes. That's it. Then we compile our graph, and this is what we get. So yes, actually, let's look at the chatbot first. I think that's a very interesting note. Here, again, this is a function, right? And here we see that in this function, we are calling an LLM, which in this case, let's see the LLM. This is LangChain. LangChain is an LLM framework, which pretty much allows you to use any kind of model with the same API. That's super handy, because in theory, you can just change your model here and use it. And that's actually a game changer. That's super handy. Otherwise, you will need to like use a specific API, for example, OpenAI's API. use their functions, use their endpoints. And if you go to cloud, you have to change your whole code, right? In this case, we just changed this name here. So yeah, we're using Gemini 2.0 Flash. Super cool model, actually. Here, we are invoking it with a system prompt. And the system prompt or the system message is just the instruction, the overall instruction for our agent, right? And this is super simple. We are just saying, hey, you're an expert currency converter AI agent that uses tools when necessary to help the user. Great. And the way we call it is that this invoke method expects a list of messages. The first one is our system message, right? But the second one is all of the messages that we have in our current state. And again, when we start or invoke our agent, we're actually calling it with a given state. Here, this UI doesn't allow you to see it, but actually what is happening is that we are invoking our graph with this state, which is literally the state we defined, right? You can see here, this is a sequence, a list of messages, right? So in the first one, instead of using the UI, let's do the raw JSON, which is what it expects. So hi there again, please convert, I don't know, $20 to cut. And you can see here that this is the same state that we expect. Again, this is a function that expects a state, as simple as that. Let's see what happens. Yeah, we have here our human message. Here we have the chatbot again, and the chatbot again calling the tools node. Going back to the chatbot. Something super handy about LangGraph Studio is that it allows you to see the state at the current state for the graph. As we can see here, we have all these, let's say, previous chats, previous messages, and these are same thread, and we have it funded with the chatbot in the same thread. So we have the same messages as before. So when we call here in the chatbot our LM, we are passing actually all our interactions with it. So you can see here that we are invoking when we just sent that message there, the last message, we were also calling it with all of our previous history. So great. Now, at this point, once we send this state, which is just the messages, we were spreading the messages here with the agent system prompt. We now get an AI response, right? That's literally Gemini responding, analyzing the context, responding. Let's see the state at the time where the chatbot responded, where Gemini responded. We see here that we have an AI message, so an assistant message, that is telling us USD to COP converter, whatever, and USD amount 20. And this is what we call a tool message. A tool message is an AI message with some tweaks. And the tweaks are, it has a tool call list attached to it. We'll see that. And then we invoke the tools. And we have the USD to COP converter. So let's actually figure how the agent is able to first convert between currencies. Again, agents are have a knowledge cut date, so they just know about certain events in the world till a certain date, right? But with tools, we can allow it to interact with external systems. And as you can see here, our agent is actually using this other function that we have here in our code. Calling an API, so we get a response from the API, and we return a new state. Sorry, we return something from the tool. We return some payload from the tool, right? And then the node is able to see, hey, okay, I call the tool, and the tool return something, and this was by return a base, target, and a rate, and it also returned the conversion itself. So then next, since our tools node always come back to the chatbot, now we have our chatbot with all this context. So now it's able to realize, hey, I have all I need to fulfill your request, which was please convert $20 to cup. And then it tells you this response. I think one of the important things here is understanding this tools node, right? What is the tool node doing? First, let's figure how we're even routing to the tools node. Again, we were looking at the state, and we have here a conditional edge, right? And the conditional edge, as I said, they are able to read the state. And so we're getting the states, we're getting the messages, and we're picking the last message. For example, here, this is the last message. We are just asking with plain Python, hey, do you have a tool calls property, and does that tool call property has anything in it, pretty much. And as you can see here, if we go to the JSON, and we'll look for the tool calls. So yeah, so that was yeah. So you see, this is another AI message without tool calls, and then we have this other AI message, but actually with tool calls. And that's when we decide, hey, you know what? We have a tool call. You should go to the tools node. But this is deterministic. We are just reading the state. We are not calling in any LM to figure this out, right? Otherwise, you go to the end node. The end node is just literally just finishing the flow for the graph. So again, this tool node is very important. As you can see here, we have an actual implementation or manual implementation for this. What we have here is util from LangGraph. So the tool node is so important that they already built it by, and this is building in their library. But we can figure what it does. So first, let's see. This tool node expects tool sequence, which is just a list. And here we pass our function, right? So think about it. We are passing a function to another LLM. So the next question is like, how is able to in the first place, like execute this function? I mean, this is just Python code, right? In my system, how is able to do that? Let's actually go ahead with that. Let's try to. So let's look into tools, right? So when we think about tools, we need to understand the why. Why in the first place? Tools allow us to, again, interact with external sentences, right? So that an LM, due to the nature, in a way, they are not allowed to get the latest data. They are trained, and when they are, and when there is training stuff, that's where their knowledge stops, right? So, but we can provide them with tools that allow them to interact with external systems. So, and the cool thing about how they made this work in the LLM world is that instead of, obviously, passing a function is not possible, but what they do is literally passing or letting the LLM know about a string representation for the function itself. And that is possible thanks to a structured output. First, let me go into, I have here a super handy example of how this looks like. So yeah, so this is our function, right? Let's say that we have a function that is the get current weather function. We have a location and a unit argument, and we return a dictionary. Let's imagine we have some implementation here, and we have these docs here, a description for the function. And then what they do with this function, once we pass it to the, in this case, LangChain does the job for us. LangChain, we pass this function, and they parse it into a JSON representation for the function. So at the end, this is what the LLM sees. The LLM sees as JSON representation for the function. So they see, hey, then you have this function. The name is get current weather, and this is what it does: is it retrieve the current weather for a specific location, right? That's it. And it has these parameters. You have the location and unit, and it defines the type and the description, and it also defines which one of them is required. So and this is super handy, and this is super, actually, I like this very much, because LLMs, yes, they are able to understand plain language. So when you pass them, instead of any other, I don't know, plugin, so this was the simplest solution for this, like letting the LLM with plain text understand that it has a function that it can call. And the way the LLM calls it is by defining or by returning. So the way it responds is with an JSON, it has a name and the arguments. It's trying to call it using JSON. Obviously, this doesn't call the actual function, but then this allows us to get this JSON and parse it and figure in our system, hey, this this name or this thing that is trying to call, we have a function for that in our system. Let's call it with these arguments. So, and that's what the tool node does. So the tool node first parses our function into a JSON representation. It lets the LLM know, hey, you have this tool, and then the LLM calls it, and that's pretty much how they work. I was also talking about structured outputs, and this is also a very important concept when working with AI agents, is that, yes, LLMs are undeterministic, 100%, but there is a way to get closer to some kind of deterministic system. But it's never deterministic, but at least you can get these structured outputs. Structured outputs are very handy. Because you are guaranteed that you're going to get a specific response the way you define it. For example, let's actually come back here real quick. So we pass, in this case, we would pass the way we want this response to be, the schema, let's say. So we say, hey, the name is a property and this is a string, right? That's the way. This is how we define the schema. So we are guaranteed that the element is going to respond this way every time. So imagine, like, that opens up a lot of possibilities, because when you work with LLMs, they are undeterministic. They will respond in whatever way they want. Given the same input, it doesn't mean that they will return the same output, right? But with this structured output, let's say feature, you are guaranteed to get at least the same schema, not the same data, but the same schema, and that's super handy. So yeah. So So this is what happens, right? So we had our tool. We pass it to the tool node. The tool node parses it to a JSON representation, and it then binds it to the LLM. And this is the process of using the LLM API, and letting you know, hey, yes, you have a tool actually, and this is the JSON representation for it. So the next time we call our LLM, we have an LLM that knows that it has tools in it. And remember that our system prompt literally says, hey, you're an expert crucial converter AI agent that uses tools when necessary to help the user, right? So when we go here, the LLM reasons about the request. And it realized, hey, you know what? Let's use this tool here because they say it is the best thing in the world to convert between USD to Colombian pesos. So let's use that. And then the tool returns its response with the conversion and the exchange rate. And then the chatbot says, hey, yeah, I get my answer, and then I can now fulfill the request for the user. Great. I think that is one of the, what you see here is the basis for any kind of agent. Having nodes, edges, also a tools node. The tools node is conditional, but in 90% of the cases, you are going to have tools. Tools are super handy for whatever you are going to, for whatever you're trying to do. So yeah, so we have seen the tools, how they are able, so how the LLM is able to actually call these tools, how our agent actually reasons about the message, and how everything works, right? Because we have this router, and we get the messages, and we say, hey, do you have a tool call? Yes, then go here, the tools, because the tools node is able to parse the response from the endpoint, from the tool and everything. So yeah, I would say that's a simple agent. Now, as you see here, I built a bunch of different agents, and this is something else that I love about LangGraph. You can have specialized agents and then be able to compose them into a bigger agent, do bigger things, right? Do like more specialized things. So yeah, for example, let's go to, let's analyze this data analyst agent, the one that we saw at the beginning. So here the state is a bit different. We don't have any messages here. And actually, let's look at the agent here. Oh, yeah. This looks like a pipeline, right? Like a, and again, LangGraph is an orchestration framework. So we have one node and another node. We are just orchestrating that flow, right? So yeah, here's the state. Let's look at the view rendered version. So we have data, any kind of data, as we see here. Oh, well, it's a string. Well, in theory, it's any kind of data. I have a task, a plan, and analysis. So this is cool. We see here, let's actually see how this works. So we have a planar node, data analyst node, the one that we see here, right? And we have the edges from the start, to the planner, to the planner, to the data analyst, and then to the data analyst to the end. Linear flow. Great. And then, yes, let's see what each node does. Here we have a planner. Before even I go with this, let me, yes, here we have a planner, and I have a super handy slide for that. Because there in here, we get into agent architectures, right? Yes, we can have independent agents. Agents are specialized, but we also can follow certain architectures to improve whatever we are trying to do. So there are certain architectures that are better for certain things, right? What we saw in the first agent with the cursor converter is actually depending on how purist you are, this is a React agent. The React agent is able to reason about the request and act upon it. So as we saw here, our chatbot was able to reason and act, hey, you know what, go to tools. Let's actually call these tools. And then back, okay, now I have this, the data that I need to respond to. So yeah, it was able to reason and act on the user request. So we also have the planning architecture, where we have agent or an LLM that first generates a plan, and then another one that executes it. And that's that comes handy, especially when you have let's say you have a powerful LLM generating the plan, and then you have an executor that is not as powerful, but it is fed the plan from the more powerful one. So you can do the work using a less powerful one, and that obviously is faster and saves you some money. There's also the hierarchical supervisor, so the hierarchical architectures, and one of them is the supervisor, and that's the one that we are, that's the final agent that we have, right? We have the reflexive or architectures. The reflexive architecture, I actually have some images there, here. Here, yeah, cool. So this is for the reflection. This is how it works. As the name implies, we have an LLM that first generates a response, and then it goes back. This can be another node or another LLM, but it can actually be itself. In this case, it's another node. And this other node, hey, it says, hey, you know what, your initial response is not as good. So it just sends like this critique to the generator, and the generator says, hey, you know what, yes, and let me improve this response. And then it goes back in a loop, and until they don't have like a good answer, they don't respond to the user. And that kind of flow allows you to have better answers. Let's look here first at the images. So this supervisor is a node that decides where to go. This the red agent that we built. The plan and execute. The one, I guess you could think about the data analyst that I have as a plan and execute. Let's go there. The only thing is that, I mean, you wanna, yes, create a plans, and then the data analyst analyze it. I actually have articles here. The cool thing about the planner, let's actually read the system for the planner. You're a planner agent. Your role is to analyze, describe, create a plan, right? And here you see we pass. So we have this state, and the planner gets the state. It expects the task and data state, and we pass it. This is something cool. So we have the system message, and we have this human message here. So when we pass this state here, and this is an article for crypto prices, right? So I can ask it to, since I know that, for example, this is a specialized data analyst, and this can also convert from unstructured to structured data, I can ask it, hey, convert this data to this article to an structure format. Cool. So let's see something here. This planner is going to generate a plan, and this is where we act on the current state, which is the state I just passed, and generate a new state. We generate a plan, and this plan can be passed down to the next node. Here we have the plan and the initial data that we get in the first step even. and then the plan for the planner. And we are able to use an analyst with a plan generated by an expert in planning, right? And we, in this way, then we get the response and we update the analysis state. Yeah, we can, as you see here, it was also able to generate JSON data from the article, right? We also have the scraper agent. This actually is even simpler. Let's look at the scraper agent, yes. And we have here, the agent is able to first build reason about our input and do something. Let's say find a good bread. Find a good bread. The query builders understand that, hey, I need to create queries for this site where we get the for this grocery store site. So because we are going to use these queries in the input field, so I need to create actually great queries for that input. So yes, and now here we get something cool about this agent that it always returns structured outputs. As you see here, and again about the output stuff, you can have LLMs that always return the same shape. Given any kind of input, you're going to get the same shape. Again, this doesn't mean that you're going to get the same data, but at least the same shape for the data. So we are going to have a name, or we're going to have a name and a list of products. Yeah, that is super handy. Actually, yes. Yeah, the scrapper, yes. I wanted to show you LangSmith, because yeah, we have been using this. Something that comes up very often is that when you're working with this kind of undeterministic agent, you always want to know, hey, but why? Why do you do that? And this is where LangSmith comes super handy, because we can observe and analyze why. Here we can see where it goes, yes, but here we can see actually why it went there, right? So we have the chatbot, and this is for the this is a trace, which pretty much shows what happened. We can see here we were working with the currency converter agent, and we set up the state, then we called it the chatbot, correct? The chatbot was using the system prompt. The chatbot did this thing here. It tried to call a tool. Then we went to the tool, and the tool returned this payload, and then used it to copy converter, analyze the state, and return a new one. Let's look at our final agent, actually. Let's do it. Let's look again at our supervisor agent. The supervisor, again, is another kind of architecture where we delegate, or in a way, an LLM, based on the current state, decides where it wants to go. And literally, that's the system message. Like we say, hey, you're a supervisor. You have 3 workers. Analyze the current state, or analyze the current task, and decide to which node or to which worker to delegate this work. And then let's go quickly to the router for our supervisor. We see that we go to the next. And the thing is, this supervisor is always returning a structured output with a next, and the next property can only be data analysis scrapper or currency converter. And this is where structured output comes super handy, right? Because we are guaranteed to have this kind of schema, and then we can make decisions on top of that. And this also, something I very like a lot about the supervisor, hey, find a good cheese and tell me the price in cup. See what it does. So the supervisor knows that it has a scraper worker that is able to, hey, this agent is actually super smart and it knows how to go to other pages, right? And then it says, hey, yes, I have the cheeses now, but then the user asks for me to convert to the currency to another currency. So and I have this worker here, and now we are able to convert to use these other workers. And again, these are our agents that we built in the past, and we are now composing them into a supervisor. Yeah, as you see here, we were able to actually get a response with the USD converted to Colombian pesos. And let's see actually the trace about why and how. So first, go to the supervisor, right? The supervisor, given this system prompt and the current state for the task, it generated this output. I don't know if you can see that. Where the next one was a scrapper. And again, we have this router function that just goes to the next. That's it, simple. And the reason why we went to find a good cheese and its price, we need to search for product information on grocery store websites. The scrapper is the appropriate worker for this task. And the task itself, search for a good cheese on a grocery store website and provide its price in USD or the local currency if available. Then let's see what happened next. Because the query scrapper, so the scrapper is not able to convert stuff. So to convert between USD into Colombian pesos. So let's see here again, the supervisor. We see here, hey, the next actually is the currency converter now given the state because I now have the cheeses. And the reason, hey, the user has requested the price for the cheese in Colombian pesos. The scrapper has already provided the prices in USD, and the task is then convert the following cheese prices to Colombian pesos. So it does all of that. Yes, this way we can orchestrate agents. Again, the idea is to work on small agents, super specialized agents, then compose them into smarter agents and do a lot of stuff with them. Yes. So here, yes, we saw LangGraph Studio, LangSmith. LangSmith again is the platform where we see the traces to understand what happened. LangGraph Studio allows you to see how actually everything is going where. Yeah. And yeah, so what's next, right? So yeah, we saw we take a look at some agents that yes are able to interact with external systems, but we can improve this by using tools to call or to get content from vector databases, pull unstructured data, PDF articles in text format, use knowledge graph. Knowledge graphs are graph databases that already define the relationship between each node. And this actually is super handy to get better responses from LLM agents. And we can use pre-built agents. This is something that I cannot show you right now because I need to close the Chrome, but I made a video actually about something super cool with, I think I have some time. I have here, before I show you, I have here another agent, which is not in the LangGraph Studio platform, but I have the supervisor with browser use agent. Browser use, we saw in our browser agent, let's see, scrapper agent. We're actually scrapping ourselves. I mean, we're just calling this function, and this is playwright. This is super annoying because you have to manually go to the page, understand how it works, right? To get the selectors and get the data. But that's not necessary. That's not a requirement anymore because we have pre-built agents that we can already use into our language stuff. And one of the things is browser use. And let me show you how that works. So this is our supervisor with browser use agent. I have to click from the terminal. This browser use agent uses multimodal elements, for example, OpenAI 4.0 or other capable LLMs, uses vision and tools to interact with websites. So in this case, we don't even need to have to scrap the data ourselves or to build these playwright scripts. We can just use vision, LLM vision, and yes, scrap data. So imagine this like in an actual website like Walmart or something. And if you are worried about these robot challenges where you have to make sure that you're not a robot, many of these agents are actually capable of overcoming that. So yeah, great. I think let's see. I think yeah, that's it from me. If you have any questions, you can look at the scan the QR, and I will be happy to answer.
So thank you, Diego, for that really interesting talk. So we have a couple of questions for you. The first one is how to go about learning LangGraph without prior machine learning related knowledge.
Right. Actually, to use LangGraph or this kind of agents, you don't need any kind of machine learning knowledge. You eventually learn some concepts and stuff, but that's not a requirement. Anyone, I would say, with some Python knowledge can start working on agents and build their own agents. Yes.
Okay, thank you. And we have another one. There is what are some alternatives to LangGraph to building AA agent?
Great. Actually, there is a, let's say, a very yes, there's a race between many frameworks because this is super new and everyone's trying to build their own framework. These big companies. There is one called Llama Index, which is an alternative to LangGraph. This is a more, let's say, managed approach where they have their own platform. If you want to orchestrate AI workflows without code, more of like visually, you can try NN8 to build like visually just grabbing, just visually building right the graph yourself, getting your data from Postgres or any kind of source, and then building your workflows. So,
Okay, thank you, Diego. I think we don't have more questions. So thank you for sharing all of this information with us, for preparing all of this for us. And thank you all for joining us today. I hope to see you at the next one. I hope you have enjoyed and see you. Bye bye to everyone. Have a nice one.